In this particular question, we've been given the irrational function h of x, where h of x is equal to x to the 3/5. And we've been asked to determine if this particular function has any points of inflection. We start by finding h prime of x, which is equal to 3/5 x to the negative 2/5, and then find h double prime x, which is equal to negative 6/25 x to the negative 7/5. Now we're going to take h double prime x and set it equal to 0, and I'm going to write the second derivative in a slightly different manner so that it's expressed as negative 6 divided by 25x to the 7/5. Now there is no value for x for which h double prime x will equal 0. However, h double prime x does not exist when x is equal to 0. Because remember, for points of inflection, either the second derivative is equal to 0 or the second derivative at that potential point of inflection does not exist. So we're dealing with the latter case. So now that we have the x-coordinate, which is 0, we now need to find the corresponding y-coordinate. So we take our x value, substitute it back into our original function h of x, and we find that y is equal to 0. So the question becomes, does the point 0, 0 represent a point of inflection? The only way we'll know is to check if the concavity changes across that point. So I write down my number line, and I place my x value of 0 on that number line. I want to test the second derivative on either side of that x value of 0. So I've chosen x equals negative 1 and x equals positive 1. When I take x equals negative 1 and substitute it into my second derivative, I end up with h double prime of x equaling positive 6/25. So I record that on my number line that I'm dealing with positive values just to the left of 0, or to the left of 0, I should say. And when x is equal to 1, I find that my corresponding value of h double prime of x is negative 6/25. So I record that x values to the right of 0 produce negative values in our second derivative. What I can clearly see is that my concavity is indeed changing across that point. So I can conclude that 0, 0 is a point of inflection.